obviously these are super, super large numbers, and you can take a look here. The exponents are smaller here than the exponents here, but then you're dividing through by a larger number in the denominator here. So you can see this is likely two numbers that are fairly close to each other. Now, just what I did, folks, is I considered the ratio. Let me show you what the approach here, and it's a common approach, and I'm just going to call this top guy A, okay, rather than have to rewrite it. So the numerator, we'll just call it A, right? And then the denominator here, we'll call it B. Okay, so there we go. Now, yeah, most of this is fairly routine. What I did, well-known result from arithmetic, when you're dividing by a fraction, you multiply by its reciprocal. It's very well known and easy to establish. And if you don't happen to remember what factorial means, this 20 factorial, what this 20 right here is actually equal to 20 factorial divided by 19 factorial. Now, if you guys aren't familiar with factorial, it just means multiply your integer portions or factors out. So this would be 1 times 2 times 3, and I'll put the ellipsis dot, 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 so we don't have to write it all out, dot, 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 and then it ends with 19 times 20. Okay. Now, 19 factorial, and I'll leave out that's 19 factorial. Okay, so now notice you get the very same thing, except you stop at 19. So you got 1 times 2 times 3, like that, all the way up to 19, right? So you can see where this 20 came from right here. This 20, because you have 20 factorial divided by 19 factorial right here. And so again, the 19 factorial is present in both the numerator and denominator, so everything cancels, and we end up with 20, okay? Now, the rest of this piece right here, going from here to here, is just the distributive property, laws of exponents. This is 20 to the first power, right? So 20 to the first power times 20 to the 19th is 20 to the 20th. And we can do nothing better than juxtapose 20 with 11 to the 19th. And so right now, you can pretty much see that the numerator is going to be larger than the denominator, but I like this step right here. The only difference between these two expressions, everything's the same except you got a 20 in the numerator, right? In these two locations. So 20 is certainly greater than 11. So that means we've conclusively shown that this expression is greater than 1. Now you can see why I called it A and B. What we know now is that A over B is greater than 1. Okay, and that certainly intimates that A is greater than B. And so the comparison ends up establishing that the left-hand side, the one with the smaller denominator, this guy right here, A, is greater than this. And it ends up being alarming, so close that you would have to do it like this. I mean, this is, these are just, you can imagine the size of these numbers, and it's very, very close. It's razor sharp on this inequality. I guess you could also have subtracted the two, and you could actually calculate the difference as some huge fraction. But I like this way better. So we have done the comparison, and we've come to the conclusion that the first fraction is greater than the second fraction. Hope you enjoy.